In section 4, we're learning about properties of real numbers. This is nothing new. You've been doing them all along. It's just that now we're kind of defining stuff. You probably already know all of these. If we just say a couple of numbers, you'll know them. All right, here's a set of numbers we're going to add. Remember the squiggly bracket here and here tells me that I have a set. We learned that in the last section. So if I'm going to add 6 and 3, the question is, does it matter what order we add them? If I add 6 plus 3, I get 9. If I add 3 plus 6, I still get 9. So the answer is no. It does not matter. What if we wanted to multiply them instead? Does the order matter there? No. 6 times 3 is 18. 3 times 6 is 18. You get the same answer. So the answer here is also no. And what that leads to is what we call the commutative property. The commutative property of addition, or the commutative property of multiplication. This would be the commutative property of addition right here. This is the commutative property of multiplication. All it says is if I take two numbers and I add them, it does not matter what order they're added in. If I take two numbers and multiply them, it does not matter what order they are multiplied in. You can switch them. Okay? All right, here's another set of numbers now. 5, 3, 4, 2. The question here is, does it matter what order we add or multiply these? If we add them together, we have 5 plus 3 is 8, plus 4 is 12, plus 2 is 14. Well, what if I did 5 plus 3 is 8, plus 2 is 10, plus 4 is 14? Was that easier to do than the first way? Kind of, yeah, because you got to the 10, and then 10 is easy to add stuff to. What about if I do 3 plus 2? What do you get? What if you added 5 to that, and then add 4? We still get 14. So you can add in any order you want. The answer here is no for addition. What about multiplication? Does the order matter there? Let's multiply across. 5 times 3 is, 15 times 4 is 60. 60 times 2 is, good, 120. All right, we went straight across and got 120. What if I did 5 times 4? 20 times 2? 40 times 3 is 120. We got the same thing, right? What if I did 5 times 4 again, 20, and then I did 3 times 2, 6. 20 times 6 is 120. What if I did 2 times 4? 8. 8 times 5? 40 times 3? Does it matter what order you multiply stuff in? No. So the answer to this question in both cases is no. You can multiply, as long as it's all multiplication, you can multiply in any order. As long as it's all addition, you can add in any order. So a lot of times what people will do is they'll add in ways that makes easy numbers, or they'll multiply in ways that make easy numbers. And that's what we're about to do down here. Before we get there, what we're talking about here, being able to add or multiply in any order, is known as the associative property. So the associative property says, here I have three numbers, A, B, and C, and I'm trying to add them together. So I have A plus B plus C. I'm adding them together. The grouping symbols here tell me that what has to happen first. A plus B has to happen first here, and then I can add C. The grouping symbols here tells me what has to happen first. B plus C, and then add A, all right? So the grouping symbols here with this definition, I know it's just letters, and that's probably confusing to some of you, and it's okay. It's like the first couple of days that we start working with letters, it's confusing. All this is saying is no matter what these numbers are here, 4, 2, 6, 4, 2, 6, I can add them this way and then that one, or I can add them this way and then that one. I can add in any order. That's all the associative property is telling you. So that's the associative property for addition. The one for multiplication is very similar. I have A times B times C. And we just said we could multiply in any order we want. So on this definition, here it's telling me to multiply these two numbers together first, and then take that result and multiply it times C, the other number. Over here, it's saying this time I want to take these two numbers and multiply them together first, and then multiply times the first number. We're going to get the same answer either way. Is that true? Yes. So that is the associative property. if it's asking you what property are we using, and you see parentheses, and there's like a bunch of terms here, and it's all addition or it's all multiplication, and on the next across the equal sign, you have the numbers in the same order, the parentheses are what's moved, that is the associative property. All right, so how we use this is if we have a list of things that we're trying to add together or multiply together, you try to add or multiply in ways that makes easy numbers. So we could sit here and like draw a line right here and add all these things up and go 5 plus 0 plus 5 plus 0 is 0, carry the 1, 1 plus 7 plus 0 plus 2 plus 5, and go through that, right? Right? Okay. But what we're going to do instead is try to add these numbers together in ways that actually makes easier numbers. So do you see two numbers or two dollar amounts that we could add together easily here? How about the ones that have the 3/4 and the 1/4? See that? What's going to happen if I add 675 and 2325 together? You're going to get 30 exactly, right? Because the 75 cents and the 25 cents adds to the $1, and then $6 and $23 is $29 plus that $1. So if I add these together, I get $30. Now I can take that 30 and add it to what? The 14? Sure. So 30 plus 14 is 44. So now I'm at 44, and what do I have left? The 2050. What's 44 plus 2050? 44, 2050. That you can also do in your head, $64.50. So it took longer than it would have if you just did this in your head, for sure, because I was explaining it and asking questions. But doing this in your head is way more powerful than trying to sit there and do the usual adding up a column of numbers and carrying the one, and then adding up and then carrying that, or even really reaching for a calculator. Mental math is more powerful than that, and you can actually get it done faster using your brain than you can typing it into a calculator. Okay? So that's what we're doing here. All right, how about evaluate 5 times 7 times 4 times 2, and then it says name the property used in each step. So we're either going to be using the commutative property or the associative property. And I want you to really pay attention to how this works. What two numbers could we multiply together to make something easy to work with? What do you think? 5 times 4 gives the easy number to work with? Is that what you want to do? Okay. So in order to do that, we want to have the 5 and the 4 next to each other. One of the properties we just learned lets me trade these two around because of the fact that if I multiply two numbers together and I swap them, I wind up with the same result. What one was that? What property did we use? We just learned it. Associative property uses grouping symbols. We're not grouping. It's the commutative property. We're just swapping places with multiplication. So I'm going to rewrite this as 5 times 4 times 7 times 2. What property let me do that? The commutative property. It's commutative property. There's two T's. Okay, so now we have 5 times 4, which is 20, times 7 times 2. Are there two numbers we can multiply together easily here? What's that? 20 and 7. What's 20 times 7? 140. So now we have 140 times 2. Is that something we could do easily in our head also? Yeah, what do we get? 280. 280 is the answer. So we really only needed to use one property before we were able to multiply. Use the commutative property to swap places, and then you can just start multiplying. In geometry next year, you guys are going to be doing things that ask you to start somewhere and wind up somewhere. Using geometry though, so using shapes and rules and theorems and things like that. But basically what we did here is sort of what we call a proof. You're going to be doing proofs this year in this class. You'll be doing proofs next year in geometry. You'll be doing proofs in algebra 2. They don't go away. They're not difficult. You just got to go step by step by step and say what it is that allows you to do that every time. So now we're just going to move on and make some more definitions for properties that we already know. Properties that are specific to addition and multiplication. Only multiplication and addition. Because subtraction and division work a little bit differently. So the additive identity property. Identity means if I do something to it, I get the exact same thing back. So if I have some number, I don't know what the number is. Maybe it's A. It could be a 5, it could be a 2, it doesn't matter. It's some number. So I'm calling it A because it could be anything. I want to add something to it. Let me go in the correct column. I want to add something to it so that I wind up with exactly what I started with. What would that have to be? 0. The additive identity is 0. If I add 0 to anything, I get exactly what I started with. So adding gives exactly what we started with. An example, let's just pick a number. 1 plus what would give me exactly the same thing back?
0.
1 plus 0 is 1. There you go. That's the additive identity property. The additive inverse property, A plus something gives me 0. The additive inverse will be that something that we put in there. And I put it in the wrong spot again, didn't I?
Yep.
Man. All right. A plus something gives me exactly 0. What would that have to be? A negative of whatever I had to begin with. Yeah. So A plus negative A gives me 0. The example would be like 4 plus what? Negative 4 equals 0. The additive inverse is the same as the word that we know as opposites. Opposite sign, same number. So if I say negative 5, what is the additive inverse of negative 5? 5. Because negative 5 plus 5 gives me 0. Okay? You just change the sign. You can keep the number. Our multiplication properties. First we start off with multiplicative identity. It's a long word. Tough to say, but it's multiplicative identity. The multiplicative identity is, I'm going to start with something. I'm going to times by something and get exactly the same thing back. What number must that be? 1. Example. Negative 5 times 1 is negative 5. So in words, multiplying gives exactly what we started with. Okay, the multiplicative property of 0. I'm willing to bet that you guys can come up with this one. I have some number. And what am I going to multiply by? Times 0. And what do I get? 0. For example, -1 times 0 equals 0. Because, exactly, and that's what we're putting for words. Anything times 0 is 0. My neighbor's beagle times 0 is 0. The multiplicative inverse is also something you've learned before. The multiplicative inverse is going to be, if I have A, I'm going to multiply times something, and that is going to give me 1. A times negative A is negative A squared. Doesn't work. So it's not negative A. A times 1 is A, not 1. So that doesn't work. A times itself, A times A, is A squared. Still not 1. A times 0 is 0. Still not 1. A times 1 is A. Let me pick a number here. See, I'm going to try to help you guys out. If I have 3/4, I want to multiply times something to give me 1. 3/4 times -1 is -3/4. Multiply by the reciprocal. That's right. So what's the reciprocal of A? 1 over A. What's the reciprocal of 3/4? 4/3. So let's use that as our example. 3/4 times the reciprocal, which is 4/3, equals, technically, you multiply across and you get 12 divided by 12. And 12 divided by 12 is 1. So the multiplicative inverse is the reciprocal. So let's talk about what property we're using in each statement. We have that first one, 42 times 0 equals 0. What property is that? Good, multiplicative. And I'm going to abbreviate, MULT, multiplicative property, PROP, of, can't really abbreviate that one, 0. Multiplicative property of 0. I like abbreviating. What's that? No. You do need to write it out. That's a requirement. But you can abbreviate. I'm okay with abbreviations. Just make sure you abbreviate appropriately. All right, next one. We have, looks like y plus 2.5 in parentheses plus 28 equals y plus, and then the parentheses are over here, 2.5 plus 28. What property is that? That is the associative property. We have the numbers in the exact same location. The only thing that moved was the grouping symbol. Now, if you're going to abbreviate this one, make sure you are appropriate. Associative property. Legal abbreviations only. Huh? How am I? I'm all right today. I'm less than superb, I'll say that. It's been all right. All right, we have 10x plus 0 equals 10x. What property is that? Very good. We are adding 0, and adding 0 is the additive identity. And the next one. Good, multiplicative identity. And we can abbreviate that also. MULT, identity. Multiplicative identity. Should try saying that sometime. Sometime tonight, maybe, during commercial breaks. Pause your game suddenly and say multiplicative, and then start playing again. You'll blow everybody's mind. You think I'm kidding? Okay, what's happening on this one? Really? You're actually right. Why is it commutative? Most people on this one would say associative. Why is it commutative? Yes, the letters here switched. The grouping symbols around the square root y and z didn't move. The letters are what moved. We swapped these two, which is a legal thing to do. That is the commutative property. Commutative. Can't really abbreviate commutative property. How about the last one? Very good. Multiplicative inverse. We have a number times its reciprocal, and that gives us one. That's the multiplicative inverse. Nice job.